Okay, so in this video we're going to go over particular solutions and how to solve non-homogeneous equations. So let's start by doing number 13. Number 13 basically just asks us to solve for the particular solution and not even solve for the coefficients. So it's meant to get used to solving these, because there's a lot of tedious work to solve for the coefficients. That's just kind of basic algebra. But we'll go ahead and solve just for the coefficients for these two problems. So first we're going to need to know two formulas. First formula we're going to need to know is the particular solution with non-complex solutions. So this is y of p, the particular solution, is equal to t to the s, a t to the m, dot dot dot, d to the t, plus e times e to the rt, where s is equal to 0 when we have a no matching root rather. S is equal to 1 when we have one matching root, and S is equal to 2 when we have double root. Matching. And that has to match like all of these. Alright, so now we need to know the particular solution of a complex involving complex numbers. And this is pretty similar. You have t to the s, a to the t, m, dot dot dot, dt, d to the t, or dt, plus e, is equal to e to the alpha t cosine t, plus, I'm going to put this down here, t to the s, where we hear f of t m dot 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 I of t plus j times e to the alpha t sine t. Okay, so let's do this problem. Now that we know these two formulas. So the first step is to solve the homogeneous equation. So we're going to get r squared plus 64 is equal to 0, because we're solving this as if it's homogeneous, and solving for r, or solving this, you're going to use the quadratic formula, and you're going to end up with 0 plus or minus 8i. So this has a complex number. So since we have a complex number, we know that we have to use this formula. Okay, so now that we have this formula, we need to see if s is equal to 0 or s is equal to 1. S is going to equal 0 when this matches this. The roots match that. It's going to be equal to 0 when they don't match. S is going to be equal to 1 when they do match. Well, here we have alpha is equal to 0 and beta is equal to 8. Here we have alpha equals 0 because you could pretend there's an e to the 0t right here. That would just be 1. And beta equals 8. So they match. So s is equal to 1. So we're going to get t, and then our m is t cubed. So we're going to have a t cubed plus b t squared. So we just kind of go down this polynomial. Plus ct plus e. And then alpha is 0, so we can just do cosine t. Plus, and then I'm going to erase this and move this down here. T, we're going to have sorry, this is going to be d, not e. Doesn't really matter. But e t cubed plus ft squared plus g at t plus h sine t. And that would be the particular solutions not solving for the coefficients for this problem. Okay, not too bad. Let's do another one. I'm going to erase this. Okay, this is similar to number 14. Y double prime minus 14y prime plus 49y is equal to 16t to the 6th e to the 7t. Okay, well, solving for this one, we gotta solve for the homogeneous equation first. So we have r squared minus 14r plus 49 is equal to 0 because we're pretending it's homogeneous. And if we factor, we're going to get r minus 7 squared. So this does not involve a complex number. So we're going to use this formula. And to save room, I'm going to erase this formula because we won't need it for this problem. But we did for the last. Now we got to determine s. Well, here, we kind of have to do one thing. We have to figure out where, what r would give us 0, because that would be a solution to our homogeneous equation. So when r is equal to 7, we get 0. So we can say r is equal to 7. So r is equal to 7 here. What's r equal to here? Well, r is the root in front of the 7t. 7t is 7. So 7 and 7 match. We get s equals 2 because this is a double root. A 7 is our solutions both times. So, plugging into this formula, I accidentally erased the t to the s that should be out in front of here. S is equal to 2. So we have t squared. Now we need to walk down our polynomial. Unfortunately here, our polynomial is 6, our m. M is the highest degree t. So we need to start with a t to the 6 and work all the way down to a constant. So b t to the 5th plus c t to the 4th plus d t to the 3rd plus e t to the squared plus f t plus g. And g is a constant, so that's our last one we have to go to, times e to the root t. Well, our root is 7, so it's 7t. And that is the answer to this problem that is the equivalent to number 14. So I hope this helps you find the particular solutions. Again, these you don't have to solve for the coefficient or find the general solutions for these two problems. So let's do one where we solve for the general solution. And to kind of put this all back together here, and figure out where everything is. So this one is the same as number 17 on the homework. We have y double prime minus y is equal to 17t plus 9. Okay, like always, first step is to solve for the homogeneous equation. We get r squared minus 1 is equal to 0. solving that, we get r plus 1, r minus 1. Well, since we have no e to the rt, there are no r's that will match. Even though we have r is equal to 1 and negative 1 down here, we have no e to the root t. And remember, determining s, the value of s in that formula, is determined by the r values, or the alpha values and the beta values. But for now, since there is no e to the rt, we can say s is equal to 0. And since s is equal to 0 and there are no complex numbers, we're going to use this formula for the particular solution. T to the s, a to the tm, dot dot dot, d to the t, plus e. E to the rt. Like I said, r is equal to 0, s is equal to 0. We're just going to be left with our highest degree polynomial is t, so we're going to be left with t to the 0 out in front, a to the t plus b, because remember we have to go down from the highest polynomial, or the highest exponential value, all the way down to a coefficient. E to the rt, well, e to the 0 is just 1. So we have a t plus b. And in this problem, first thing we need to do is solve for y prime. So y prime of p is equal to a, and y double prime of p is equal to 0. And we plug these in. So we have 0 minus a t plus b is equal to minus b, because there's a negative out in front of that y, is equal to, and this is negative 2 in the problem, I forgot to write that down, negative 17t plus 9. And now we have to solve for a and b. Well, we can do this by solving or grouping the t terms rather. So we have negative a is equal to negative 17, and negative b is equal to 9, and we get a is equal to 17, and b is equal to negative 9. So solving it, the general solution. Okay, so I'm going to keep our particular solution. I'm going to write this here. Our particular solution is going to equal a, since a is 17, 17t, plus b, well, b is negative 9. So that's our particular solution. But this question asks for a general solution. And our general solution is the homogeneous solution, which I just erased, but it was c1 e to the t, because it was a double root, plus c2 t e to the t, negative t. Oh, it was not a double root. I'm sorry. E to the negative t. Plus our particular solution, 17t minus 9. And this is our general solution. And basically the way we solved it was we solved for the homogeneous equation, that's this part. And then we also solved for the particular solution, that's this part, and we just added them together. And that is how you solve these equations.